is successfully, right? You will get an email, right? Your order is placed successfully, that email you will get it, right? So email service is going to send an email to the customer registered email ID as well. SMS service will be spent. SMS service will be sent an SMS to the customer on the registered mobile number. Okay, so that your order is successfully placed and this order ID, something like it is SMS service. Then packaging, shipping. This is the regular flow. This is a regular flow. Okay. Once order service payment is completed, it will call stock service, it will call email service, it will call SMS service, it will call package service. Okay, let me repeat here, guys. Once order service payment is completed, after unsuccessful completion, stock service will update the inventory. Email service will send an email to the customer email ID, will send a SMS to the registered mobile number. Packaging, shipping will start. Okay. So what could be my code here? Just like I'm going to write a normal pseudo code, guys. I'm going to write a normal pseudo code, not exactly code. Okay. But I'm going to write a code in a couple of minutes. Okay. Right. So the pseudo code is yes. Within order service.java, I'm writing within order service.java. Okay. What code I will write within order service.java is I am going to write if order object dot get payment object dot get status is equal to success. If order payment object is success, then I will call I'll call stock service dot execute with order object. I'm going to call. Then email service dot execute ord object. Next, SMS service dot execute ord object. Next, shipping service dot execute ord object. So this is my typical code here, a pseudo code. Okay. But there is a problem with this code, guys. Sir, I'm reteaching again. I am explaining the purpose of why event-driven architecture we need in microservices in the backend. What is the necessary of event-driven architecture? Typically, we use the event-driven architecture only in the front end only. As of now, we used only in the front end. Okay, but typically we are going to have a middleware services, the event-driven architecture. I'm giving a real-time example. Okay, my scenario is once order payment is successful, stock service will be updated, email service will be triggered, SMS service will be triggered, shipping service will start. These are the 4 events that are associated with my Amazon order. Okay. Now there is a problem with this kind of architecture. What is the problem is, once I move the code to the production, customer will ask it to me, sir, there is a problem, sir, in this code. Can you call stock service at the time of shipment only? Can you update the inventory? Can you update the inventory at the time of shipment? Because, for example, sir, summer, everyone orders ACs, correct? Now I have only 20 units of AC. I ordered, 20 people ordered, there is no inventory. And still some people are looking. If I update the inventory before shipment, shipment will take 4 days, right? Now, if I update the inventory, it's a challenge for me. What I will do here, whenever my shipment is delivered in the customer location, if the AC is delivered, at that time I'll update my stock. Remaining times I will not update the stock. Updating the inventory when the product is shipped, not immediately when the product payment is completed. I don't want to update the inventory, stock inventory, after the payment is completed. I want to do it shipment time. Once shipment is received, that time, once customer accepts, yes, I need this order, I need this product, that time I will update the inventory. Meantime, you can have n number of different options where the developer is going to consider. Okay. Customer tells that a small if condition, man. Okay. What is that you need to write here? What exactly the if condition I'm looking? What customer is asking? What is the customer requirement is? Okay. The customer requirement is, if shipment service dot get shipment status is equal to shipped, that time I need to call stock service dot execute of ORD object. This is the piece of code their customer is looking. Okay. So what customer is looking? He want to update the stock service only when the shipment is done. Or else, this is one type of change may come. Another change is, okay. Another change is, maybe customer is also asking, sir, along with these 4 services, can you also include review service? I want a review service also need to be added. Customer may ask any requirement at any point of time, right? What customer can ask actually? Can you add review service also for the product reviews? Execute of ORD object. So customer may ask some changes in the workflow. Customer, once the product is shipped, okay, he may ask some status and he will give some changes. I need 2 changes, sir. You need to update the stock, not immediately. After shipment is done, then only update your stock. That's the first thing. Second thing is, you can add a review service in the workflow. How better you can handle? How to handle this situation? Okay. Sir, what is the situation here? I will go to order service.java. I will write the code. But to keep this code in the production, what I need to do? Sir, development is easy, sir. There is no big deal. I can write a code easily. I can write the code. But keeping this code in the production is a challenge. Keeping this code in the production is a challenge process. Why complex or why difficult? Because I need to stop the order service in production. I need to deploy a new order service with the latest code. I need to roll out new order service. I need to give a new order service. I need to drop the old order service. I need to keep the new order service. So, because if order service is stopped, even though other services like SMS service, email service, stock service, shipment service, even though they are up, but if order service is down, you cannot do anything. The entire system will be stopped. Entire system will be stopped. So customer is asking any some changes. You should not think that entire product will be stopped. For example, did you saw Google? Anytime it was down? Was it down anytime? AWS, Amazon, anytime it is down? Because these architectures and the forward strategies which is going to impact, which is going to bring some impact. Okay. So my point here is, if there is a small change in order service, if it is stopped in order service, everywhere it is going to have an impact. That is the problem. If I have a critical microservice and the critical microservice is looking for a code change, all the other services also up, they cannot do anything. They should follow the simple program and practice. But event driven architecture, they proposed a solution and they gave a solution, and I'm going to showcase the code. Okay, I'm going to showcase the code to everyone. The problem is order service is tightly coupled with stock service. Order service is tightly coupled with email service. Order service is tightly coupled with SMS service. Order service is tightly coupled with shipping service. Order service is tightly integrated or tightly coupled to SMS service, email service, package service, as well as order service. All these layers will be typically important when this particular concept is discussed. Okay. I need a loosely coupled architecture between these services. I need a loosely coupled architecture, guys. What do you mean by loosely coupled architecture? Okay. Order service should not know that it is going to call stock service, email service, SMS service, shipping service, and review service. They should not know actually. Order service should not know that they should call these services. And stock service should not know that it is called from order service. Email service should not know that this service is called from email service. SMS service should not know that this service is called from there. So my intention is, I need a loosely coupled architecture between all microservices: order service, stock service, email service, SMS service, shipping service, review service. All these typical microservices. Okay. I need a loosely coupled architecture. The meaning of loosely coupled architecture is, order service should not directly call these services. They should not call. There is no direct communication from order service to different microservices. So that flow, that is called as a workflow. Okay. What is the solution is, The solution is typically order service will have a queue. Okay, order service will have a queue. Order service will push the data to the queue. Okay, they will push the data to the queue. The code in order service is, I have a queue, I will keep that order in the queue. Whenever item is placed into the queue, email service will work on it immediately. Stock service will process immediately. SMS service will probably immediately, and package service will embed. I am introducing a queue. My order service functionality is, once the order is placed in the queue, once order is placed in the queue, automatically stock service, email service, SMS service, package service, all these microservices will read the data from the queue and it will process. Understand? That queue is called as an event. The queue itself is called as an event. And this entire architecture called as event driven architecture. The queue itself is called as an event. Okay, and this entire architecture is called as event driven architecture. So order service should not know that it is going to call stock service. Order service should not know that it is calling email service. Order service should not know that it is calling SMS service. Order service should not know that it is calling shipment service. Now, a queue is introduced between these services. The communication will happen through that queue. Order service will keep the product or keep the order ID in the queue. Once item is placed in the queue, all the remaining services will be up and running. Stock service will be taking care. Email service will be taking care. SMS service will be taking care. Package service is also going to taking care. There is a queue is introduced. Now this is completely controlled by event driven architecture. Event is queue. Placing the data into the queue, that itself is the event. We don't have buttons, we don't have radio buttons, we don't have checkboxes, we don't have any other things. In the middleware side, we should have only an event like queue. Once item is placed into the queue, it will update the data to other services and other services will be impacted. Okay. Here I have a workflow system like RabbitMQ or ActiveMQ or Kafka. I will introduce the workflow system. I will configure order service queue is monitored by SMS queue, stock queue, email queue, package queue. I'll configure these microservices to this particular queue, and we can design the real event driven architecture. Like queue is monitored and entire workflow system will take care. Now, what is the problem here? I'll take the two problems here. Order service code will never be changed. Order service always it pushes the data to the queue. Order service will always pushes the data to the queue only. That's the order service code. Any change I want to do. Now I want to introduce a review service. I will add that review service to the workflow. I have a workflow, right? The workflow is nothing but it can be RabbitMQ flow, Kafka flow, ActiveMQ flow, whatever it may be. And I'll configure email service, stock service, SMS service, package service to that particular queue. I can add a review service also. No need to stop order service. No need to do any queuing mechanism. Nothing to be done. It's a simply without any downtime, you can immediately place the order. Okay. So this queue will be managed by the workflow system. That kind of architecture is called as a event driven architecture. So that kind of architecture is called as what? Event driven architecture. Okay. This is a high level introduction of event driven architecture. Okay. And what exactly the event driven architecture? A high level introduction. So as I mentioned here, no, by default, queue will always work. We don't have a case where queue will not work. Okay. So guys, any technical questions or anything are there, I will take it up at the end, as I mentioned already. Okay. So we don't want it's not a database. If our database is changed, again change. Okay. A queue is a advantage which is managed by the workflow system, which can be taken care. Okay. Right. Now here, there are powerful systems are there with RabbitMQ or ActiveMQ or Kafka or any other things. They are powerful here, which is going to balance this particular architecture. Okay. So here I am going to have a order object. This is my order object. Order ID, customer name, email, zip code, mobile number. This is my order data. Okay. This is my order data. Order ID, customer name, email, zip code, mobile number. This is my order data. Okay. Now here I am typically having different microservices. Order microservice. This is order microservice. Okay. And stock microservice, SMS microservice, shipping microservice, review microservice, email microservice. Email microservice will send an email. Order microservice will process the order. Review microservice will review that. Shipping microservice will start a shipment. SMS microservice will send the SMS. Stock service will order the stock, will update the stock. Event driven architecture is typically whatever we say is a middleware which is managed by the queue. This is the workflow system. Event driven architecture is a workflow system. Okay. So this is a project understanding. Okay. I don't want to go inside that actually. Okay. Because I'm going to take a real time example here. So here, I don't want to go any theory wise here. Right. As of now, I am not adding any review microservice here. I'm not adding any review service here. I'm going to write just like I'm commenting related to review service. I'll explain you real time perspective. Okay. Right. Now here I am starting my order microservice. I mean, even workflow system. I'm starting my workflow system. It's going to take a couple of seconds. Yes, it is a workflow system. It is done. And I'm starting my email microservice. I'm placing shipment microservice. I'm starting SMS microservice. I'm placing stock microservice. I'm starting stock microservice. So here, totally, we are having workflow system as a one microservice, email service, shipment service, SMS service, stock service. All are running. Okay. Let me go to email service. Let me clear the console. Event driven architecture console is cleaned up. All consoles I'm clearing up. Yes. Okay. Now I'm starting my order service. My actual order service. I'm going to start it. Now everything is started, sir. Everything is started. Okay. My workflow service, you see here, this is workflow service, email service, shipping service, SMS service, stock service, all microservices. Order is a microservice. Microservice 1, 2, 3, 4, 5, 6. Total 6 microservices I have here. Okay. That is what my diagram, guys. My 1, 2, 3, 4, 5, 6. This is a workflow service, order service, stock service, email service, SMS service, shipping service. And I didn't add it review service yet. Okay. Now I am placing an order. This is my endpoint. Localhost 8081 Amazon/order/process order. Okay. Amazon slash. Okay. Amazon/order/process order. This is my order ID 101. Customer name Vijay Kumar. Email is, this is my email ID. Zip code is this, and this is a mobile number. I'm going to process this particular first customer. Okay. So I'm hitting a rest call and I'm clicking that. Here you'll see here, one by one you'll see here. Email service successfully sent to the customer email ID Viju. This is my email ID for the customer Vijay. Email service is automatically triggered, right? Shipment service, shipping service started for the customer Vijay Kumar for the zip code 5,37,000. SMS service successfully done with the customer with mobile number. And order service is placing an order. Okay. So everything is done, right, guys? Email service is sent an email, and shipping service is started. Shipping service is started. SMS service is sent an SMS. Stock service is sent a update to stock, and order service which is going to process it. Okay. Now let me go to clear this everything. I'm clearing everything. Yeah, everything is cleaned up. Now I want to add a review service. Okay. I don't want to stop order service, guys. That is my target. I don't want to stop this order service. If order service is stopped, other services also impact. I don't want that, right? What I will do here in the workflow service, I'm going to workflow service. I will only stop this workflow service. Only workflow service I stopped. Okay. And I added review related stuff, review service. I'm adding this. This is a review service which is there. Just I added that. And I'm adding event driven architecture here. I'm running again. Only workflow service I'm running again. Only workflow service. I started the change and I'm starting here. I didn't stop the order service. Now it is started. And I'm going to start review service also. I'm going to start review service also. Just I only stopped the workflow. I only stopped the workflow. I stopped only. I added the review service. I started the review service. Okay. So here you see review service, event driven architecture, order service, stock service, SMS service, shipment service. Yes. Now I'll place an order, same order 102, order ID Sandhya at gmail.com, 5,72,000, some dummy mobile number. Next order. Okay. Sir, I didn't stop my order service. I didn't have any impact. Order service is still there. I only stopped the workflow service. Nothing else I stopped here. My all microservices are still intact with each other. Okay. Now, you saw here. One by one, we'll see here, guys. Email service, email successfully sent to Sandhya at gmail.com for the customer Sandhya. Email service is triggered. Shipping service started for the customer Sandhya for the zip code 5,72,000. SMS service successfully sent for the customer Sandhya. Mobile number is this. Stock service successfully saved for the customer for order 102. Then new review service, review started for the customer Sandhya. I was able to add a review service without stopping order service. I didn't stop this order service at all. Without stopping order service, I was able to achieve a dynamic change. Okay. It is going to take a change. This is typically a sample example of an event driven architecture. The main purpose of event driven architecture is if one service is stopped, it will not have an impact to other service. If one service is stopped, it will not have any impact to other service at all. Okay. Microservices are not like corporate hospitals. A sample sarcastic thing. Microservices are not corporate hospitals. Why?